Are there limitations for the strength of radio signals? Yes, there are security limits, and we are going to take a closer look at some examples. I can already reveal that there will be surprises. And there are limits on the maximum exposure to radio waves. And to get straight to the point, that radio wave exposure doesn't make us sweat. A lot of clever people thought about the issue, and regulations were then derived from this. The regulations are not exactly the same worldwide, but they are very similar. You can find a link to it in the video description. The most important limitation values ensure people's health. The FCC, which is the Federal Communications Commission, has defined limits for controlled exposure, for example for communications technicians at work and for the general public. The graphic shows the safety limits in milliwatts per centimeter square for a frequency range from 0.3 MHz to 100 GHz. On the far left we have the long wave range, where the maximum allowable power density is 100 milliwatt per centimeter square. Then comes the shortwave range, where broadcasting, amateur radio and a lot more takes place. Here the limit value decreases depending on the frequency. Particularly low limits apply in the 30 to 300 MHz range. And then there is another area in which the safety limit increases as a function of frequency. This range is heavily used by cellular services. For frequencies above 1.5 GHz, the limit remains constant at 1 milliwatt per centimeter square. In the corresponding tables we also find the limitation values for the electric field in volts per meter, the magnetic field in amperes per meter, as well as the already mentioned maximum power density in milliwatts per centimeter square. A detail here is that with controlled exposure, the exposure is averaged for 6 minutes. The maximum exposure of the general public is lower, and it is averaged over a 30 minutes period. Above 300 MHz, it obviously no longer makes sense to consider the electric and magnetic field strengths separately. This is actually logical, because for a short wavelength both fields are always present. Therefore, only the power density is considered, which is the product of the electric and magnetic field strength. The power density, or strictly spoken the power flux density, can be calculated very easily from this formula. It results from the transmission power divided by 4 times pi times the squared distance r. In the following, we will use this equation to calculate interesting scenarios involving different radio services. By the way, I made a video about measuring my personal exposure to radio waves in my office. I linked the video in the top right. I like to explain such things using an Excel graphic. As promised, let's do a few examples with it now. As always, you can download the tool below. In our graphic we can already see the safety limits that we have already discussed. Let's just see where certain radio services fit into this chart in realistic scenarios. I have prepared a few practical examples here. There is an amateur shortwave station, a cellular base station equipped with 10 transmitters, a smartphone, a DECT cordless phone and a very powerful radar. We can enter the transmission power, the frequency, the duty cycle and the distance for all transmitters here. The shortwave station works with 59.8 dBm effective radiated transmission power, which corresponds to about 750 watts. And the transmission frequency is 7 MHz, and the duty cycle for voice radio is a maximum of 10%. The radio amateur who operates the station is sitting right under the roof. The distance to his Yagi antenna on his roof is only 3 meters. In our graphic we can now see the exposure for our radio amateur. It is surprisingly far below the safety limit. The upper end of the red line marks the peak value, the lower end marks the average exposure. The mobile radio base station with its 10 transmitters effectively transmits 60 dBm and works in the 960 MHz band. The maximum duty cycle within 6 minutes is 60%. A person works on the neighboring roof and is about 10 meters away. As we can see, although the person is in the main beam direction, the exposure is more than 2 orders of magnitude below the safety limit. And then we have a smartphone that transmits 29 dBm at 860 MHz. The duty cycle is 10%, and the distance to the user's head is as usual only 1 centimeter. Oops, here we actually reached the safety limit with the peak value. Amazing, isn't it? But the average value is below that, and in addition, the maximum transmission power is only used in rare cases. The situation is similar with our DECT cordless telephone, which operates at a level of 24 dBm at 1800 MHz and has a duty cycle of 4.2%. However, it is still almost an order of magnitude below the limit value. Finally, we look at our radar with an effective pulse power of 120 dBm, which corresponds to a stunning 1 gigawatt. It works at 5.7 GHz. The duty cycle is of course low, since it only emits short pulses. Suppose an aeroplane accidentally flies through the main beam in only 1000 meters distance. Okay, that would be no danger to the people on the plane at all, but we will see later why the pilot should never fly a course close to a strong transmitter. Of course, I was curious how the scenario in my own office looks like in this analysis. As said, I measured all of this in a previous video and made some interesting comparisons. If you are interested in such things, then it might be worth subscribing to the channel. The insights. Due to the limitation values that apply to people and the environment, we shouldn't really have anything to worry about RF power. Our analysis shows that in everyday life we almost never come close to these limits. Except, and this is amazing, when we put our cell phone directly to our ear. In this case we are actually in the range of 1 milliwatt per centimeter square. All other exposures are orders of magnitude lower. And there are many other interesting scenarios that you can analyze yourself. Just get the tool for it. Electronic devices such as radio receivers are much more sensitive than humans and can be significantly disturbed by unwanted radio waves. That's why we will take a closer look at EMC effects in the coming episode. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.